Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today we are going to discuss two cases which are related to cone. Now in the first case we are going to draw the isometric projections of the cone, whereas in the second case we will be discussing about the isometric projections of a cone which is resting centrally on top of a square prism. So let us begin with the isometric projections of the cone. So here we have been provided with a right regular cone of diameter 60 millimeter and height 80 millimeter resting on its base on the ground, and we are required to draw the isometric projections of the cone. So in the top view we can get the true shape of the base on the horizontal plane. So the diameter of this cone is given to us as 60 millimeter, and in the front view we will be able to get the 80 millimeter as the axis height, and this triangular shape will be the front view of the cone. Now we have to draw the isometric projections of the cone. Let us start with that. Now in the isometric projection, the first thing which needs to be accomplished is construction of the isometric scale. So in the isometric scale, the true length will be drawn at an angle of 45 degree and the isometric length will be constructed at the angle of 30 degree. Then the true length distances will be marked, right? And then from the true length we are going to draw perpendicular onto the isometric scale, and all the dimensions which are given to us, they will be converted into the isometric length dimensions, and only those dimensions we have to draw in the isometric projection. So to begin with, we have got the horizontal ground baseline, and then the x-axis and z-axis, that is the isometric axis, they will be drawn at angles of 30 degree each. Now we can see that this is the top view of the circular cone, which is a circle over there, and we already know that we cannot draw the circle straight away onto the isometric projection. So circle will appear to be an ellipse in the isometric projection. So what we have to do, we have to inscribe this circle into a square, and the dimensions of the square will be once again 60 by 60, because the diameter of this particular circle happens to be 60 millimeter. Now this square we are required to construct in the xz plane. You see, this is the x-axis and this is the z-axis, and since this cone is resting on the ground on its base, so we have to draw this square onto the xz plane. So here from this particular point of the ground we are going to mark 60 millimeter edge length of the square on the left hand side, and from this point once again we are going to mark 60 millimeter edge length of the square along the z-axis over there, right? So 60 millimeter edge length we have constructed along the x-axis, that is the isometric axis, and once again 60 millimeter edge length we have constructed along the z-axis. Now we are going to draw two isometric lines over there. So this line is corresponding to one of the edges of the square, and this will be parallel to the isometric axis, which is the z-axis over there, and this edge length will be equal to 60 millimeter. Similarly, this edge length we have drawn parallel to the x-axis, that is edge length of 60 millimeter. So this edge length is also 60 millimeter. Now we have been able to draw this square which was inscribing this circle over here. Now having drawn the square, and we know that this square is appearing like a rhombus in the isometric projections, and what is the characteristic property of the rhombus? it will not have both the diagonals equal to each other. So the rhombus will be having one diagonal bigger and one diagonal smaller one. So the bigger diagonal of the rhombus, it is called the major diagonal of the rhombus, whereas the smaller diagonal of the rhombus, it is called minor diagonal. So you see, the point of focus is this minor diagonal. So these are the two corner points of the minor diagonal. Now what we are going to do, we are going to obtain the midpoints of all the four edges of the square. And once we obtain the midpoints of all the edges of the square, now from these two corners, I am going to draw the projectors. Starting from this corner, there are two opposite edges to this corner. One is this edge, another one is this edge. Now I am going to draw two projectors from this particular corner, right? So from this corner, first projector will be joining the midpoint of the one edge, which is the opposite edge. Similarly, the second projector I will be drawing, which is going to join the opposite edge midpoint over there, right? So there are two opposite edges, so the two midpoints are available. Then similarly, from the other opposite corner of this minor diagonal, once again, this minor diagonal corner will be joined with the help of a projector with the midpoint of the opposite edges. So one edge is this one, and again another edge is this one. So this will be my second projector over there. So the construction of cone will be done by using the four center method, that is this ellipse that we are going to construct first of all. So the construction of ellipse will be following the four center method, and as the name suggests that we are going to carry out the construction of the ellipse using the four center method. So let us work out those four centers. So these four centers, they are C1, this is my center 1, this is my center 2, this is my center 3, and this one is my center 4. Now you see what I do with center 1. I'll keep the needle of the compass over here. Open compass is equal to this distance. Please check. I have to open compass equal to this distance or open compass equal to this distance. So both the distances, they are equal. Then from C1, my needle of the compass will be here. By opening compass this much, now I am going to draw a perfect arc starting from this midpoint to this midpoint, right? So the first arc has been drawn. Similarly, from the point C2, again I will be opening my compass this much or equal to this distance, right? And then I will be drawing the second arc using this compass with C2 as the center. Now the third arc will be drawn through point C3. So from C3, I will be opening my compass equal to this distance or equal to this distance. And then once I open this much compass, I am going to draw the third arc with C3 as the center point and this distance as the radius. Then C4 is my fourth center point. Again, I will be opening, radius is equal to this or radius is equal to this, and with C4 as the center, I will be drawing the fourth arc. Now having completed this ellipse, you can see this is a perfect ellipse that we have been able to draw, and it is a geometric construction. Now we know the height of the axis of this cone is equal to 80 millimeter. So this is the center of the square or center of the ellipse. So from this center, I am going to now draw the axis height of this cone is equal to 80 millimeter. And please note that all these distances, they will be isometric distances. So please check. This is the distance from O1. This is the point O of the apex. So this distance of the axis happens to be 80 millimeter. That is the isometric distance 80 millimeter. Now I have been able to locate the apex point of this cone, and then this is the point O. And then from point O, I will be drawing two tangents. One tangent to this ellipse on this side and another tangent to the ellipse which will be lying in this direction. Now these two, you see, projections which I have drawn, so these will be drawn dark because they are going to define the boundary of the cone. And then this portion of the ellipse I am going to darken because this is visible to the observer, whereas this internal semicircle which is there, that is the 50% of the ellipse. So this is not visible to the observer. So this will be left as it is, that we have drawn this using the 2H pencil line, right? So this portion of the ellipse will not be darkened. So this is the portion of the basic, you see, circular portion of the cone which is not visible to the observer. So now I can darken this portion. So this completes the construction of the cone in the isometric projections, right? So this is the procedure for working out the isometric projections of the cone. Now the next one is that we have to work out the isometric projections of the combination solid, and in this combination solid we have a cone which is resting centrally on top of a square block. So first of all we are going to carry out the construction of a square block. So this will be followed by construction of a cone on top of the square block. So let us read out the statement. So we have been provided with a right circular cone of diameter 30 millimeter, axis height 36 millimeter. It is resting centrally on top of a square block whose edge is 48 millimeter and the height or the thickness is 22 millimeter. So we are required to draw the isometric projections of the combination solid. So once again, the isometric scale will be drawn to begin with, and all the distances which are given to us, they will be converted onto the isometric scale. So once we get the isometric scale distances, those distances we are going to plot in the isometric projection. So once again we are going to start with construction of the horizontal ground line or the datum line. So we'll be marking a point over here, and once we mark a point, then this is my x-axis, this is my z-axis, and the height will be located along this y-axis. So these are three isometric axes over there. Now let us start with construction of a square block. So in the square block, basically the square block, it is resting on the ground on its square base. So since it is resting on the ground on the square base, what is the edge of the square? This is equal to 48 millimeter. So we are going to work out the isometric length corresponding to 48 millimeter, and this isometric length I am going to plot along the x-axis and along the z-axis, because the square base, it will be located in the xz plane over there, right? So xz plane is going to contain the base of the square block. Now let me draw it. So please check it. This is the 48 millimeter edge length of the square that we have marked, right, along the z-axis. Similarly, we are going to mark 22 millimeter thickness of this particular square block. So this is drawn along the y-axis, and then another edge which will be equal to 48 millimeter we will be drawing over here. But then we have completed this face of the square block, that is the right hand facing this rectangle we have drawn, right? So this is the height, and this is also the height which is equal to 22 millimeter, and this edge is parallel to this edge, and this edge is also parallel to this edge over there. Now since we discussed that the base of the square block, it will be resting on the xz plane. So along the x-axis, once again 48 millimeter edge length has been drawn, and similarly I can draw 48 millimeter over here and 48 millimeter over here, but these two edges, they will not be visible to the observer, so we can omit them if we wish. So we need not draw even those edges which are not visible. So this was the right hand face which we had drawn. Now this is the left hand face of the square block. So in the left hand face, this edge is equal to 48 millimeter. This edge, again it is parallel to the isometric axis. So this is the isometric line. Similarly, this isometric line is parallel to this isometric axis over there. So this edge, vertical one, it is equal to 22 millimeter. This edge, it is also equal to 22 millimeter, and this is also equal to 22 millimeter. Now I need to complete this top face of the square block. So what I'll have to do, two edges I'll be showing it over here, but I am not going to do the darkening of these edges because these edges will be covered by certain portion of the circular cone which is to be located on top of the square block. So that is why some portion of this particular edge and certain portion of this edge, it will be covered by the cone which is going to rest centrally on top of the square block. So this completes the construction of the square block. So having worked out the construction of the square block, then the next thing is I need to plan the location of this cone on top of the square block such that the cone will be resting centrally on top of the square block. So please see, I have evaluated the midpoint of this edge and midpoint of this edge. So the center line has been located. Similarly, I have located the midpoint of this edge and midpoint of this edge has also been located. So once these 2 points they are obtained, again a center line has been drawn. So this gives me the central location of the cone. That is, if I draw the cone over there, the center point of that cone will be lying at this particular position. Now what I need to draw a cone over there, I know that I cannot draw the circle in the case of isometric projection. The projections of the circular nature which correspond to the base of the cone, they will be represented in the isometric projections in the shape of an ellipse, right? So circle appears to be an ellipse in the case of isometric projection. So what is the diameter of the circle? The diameter of the circle happens to be 30 millimeter. So since the diameter is 30, and as usual we are going to assume that this circle has been inscribed within a square. So what will be the edge of the square? The edge of the square will be equal to 30 millimeter. So here on top of the square block, I need to draw or construct another square in isometric projections such that the two edges of the square will be equal to 30 millimeter each. So what I have to do, please check. How much is this length? How much is this length? Both these edge lengths corresponding to the square block, they are equal to 48 millimeter. Please check. This is the 48 millimeter square. So since I have got total distance available on the top, this is 48, this is also 48. And how much distance I need to be located centrally for construction of the square corresponding to the circle? It is 30 millimeters. So what I will be doing? From these two, you see, axis lines, I will be drawing two pairs of parallel lines which will be at a distance of 15 millimeter from the axis, from here as well as from here, right? So let us take up this axis line first of all. So this is my first axis line. So what I have done by constructing these two projector lines, this projector line has been drawn with an offset of 15 millimeter from the axis towards the left. Then this projector line has been drawn with an offset of 15 millimeter from the axis line, so that the total distance between these two projector lines, this will be 30 millimeter. So these are two edges which are parallel to each other at a distance of 30 millimeter. Now with respect to this axis, once again I am going to draw two more projector lines which will be again having an offset of 15 millimeter from this axis line or this center line over there. So once again the distance between these two projector lines will be how much? 30 millimeter. Now by virtue of drawing these four projector lines, you see I have been able to obtain a square, please check, on top of this square block, and this square, it is resting centrally on top of the square block. Now I know that square appears to be a rhombus in the isometric projection. So this is, I have drawn a square, but it is appearing to be like a rhombus over there. So what is the characteristic of a rhombus? It will have one longer edge and it will have one minor edge. So this is my minor edge, this is the major edge of the rhombus over here. Now what I need to do, my major focus of attention will be this minor edge. Now you check, I have already obtained the midpoint of the four edges of the square. That is, the square was of 30 by 30 side. So if this is 30 by 30, so total was 48. So 9 millimeter is left from this edge, 9 millimeter is left from this edge, 9 millimeter distance is left from this edge, and 9 millimeter distance is left from this edge. So this is 30 by 30. Now once I have drawn the square, I have obtained the major axis as well as the minor axis. Now the midpoints of all the four edges, they have also been obtained. Now from these two corner points of the minor diagonal, I will be joining the opposite midpoints of the two edges by drawing two projector lines over there. You see, two projector lines have been drawn from the first corner of the minor diagonal, and these projectors will be joining the midpoint of the opposite edges over there. So there are two opposite edges, so both of these midpoints of these opposite edges, they will be joined. Similarly, from the second minor diagonal, once again two projectors they have been drawn which will be meeting the midpoint of the opposite edges of the square. Now the four centers, they have been obtained. So please check, this is my C1, this is C2, this is C3, and this is C4. Now I am going to look for the construction of the ellipse which will be representing the circular portion of the cone onto the isometric projection. Now with C1 as the center, please check, I will be opening the radius of the compass is equal to this much or this much, and then I will be drawing the first arc over here. Please see, the first arc has been drawn with C1 as the center, and radius is equal to this distance and radius is equal to this distance. Similarly, with C2 as the center, what is my radius now? Radius is this one. This is my radius or this is my radius. So I have drawn the second arc. Then with C3 as the center, these are my radii which are equal, and then I will be drawing the third arc over there. Then this is my C4 fourth center. So this is my radius and this is my radius. So this will be my center point, C4 point, open compass this much and draw the fourth arc. So this completes the base of the cone over there. Then how much is the exit height? So this is my center point. Please check over here. This center is my center point of the base. Now I need to locate the apex of this cone. So in order to locate the apex, I need the axis height. So the axis height of the cone is given to me as 36 millimeter. So from this point as the center, I will be drawing the axis height equal to 36 millimeter. So please check, the axis height we have drawn equal to 36 millimeter, and once the point O is located, from the point O, I will be drawing tangent to the ellipse on this side. Again from the point O, I will be drawing a tangent onto the ellipse on the right hand side. Now I can darken the points. So all the edges which are visible to the observer, they will be darkened. So please check, these two slant generators, they will be visible because they form the outermost portion of the cone, and then this portion of the ellipse is not visible because it is lying on the back hand side. So this portion of the ellipse is visible to the observer. So this portion I am going to darken. So I have darkened this portion, and then we can check this edge. So regarding this edge, this portion of this total edge has been covered by this cone. Similarly, this portion of this edge has been covered. So this portion which has been covered, this portion which has been covered, they will not be darkened. So the remaining portion of the top surface of the square block will be darkened to complete the construction of the isometric projections of the combination solid. So here we can see that this is the combination solid in which the upper solid happens to be a cone and the bottom solid happens to be a square block. So with this, we are going to complete this discussion about the construction of the isometric projections of the combination solid. So we'll be continuing with few more cases of the isometric projections. in the coming lectures. So this is all for today. So thank you very much.